Hey everyone, welcome back to Safety Simplified. In today's video, we are going to work on one of the tutorials of SEDFOAM 2D Pipeline Scour. If you have interest in sediment transport, marine engineering, or wanted to get your hands dirty in SEDFOAM, you are on the right place. So let's get started. Okay, so first of all, I wanted to apologize to you all that I cannot upload video from last 1 month as I was busy with some work and that's why I couldn't get the time. Okay, so let's start today's tutorial. So first we'll go inside the set form and then we will go inside tutorials, go inside RAS, and here you can find 2D pipeline scour. Okay. So I'll copy this to our home directory, press CD to come our home directory, and yes, it is here, home 2D pipeline scour. Okay, so okay, yes, all right, so let's go to all run. Okay, so the first command is don't discuss on this thing. The first command is block mesh. What block mesh will do in 2D pipeline score, basically it will create an rectangular mesh. Okay, so let's run it and check what it will do. Okay, so rectangular mesh has been created, so let's make an foam file. Okay, and then .exe foam.foam. And yes, here you can see that a rectangular domain has been created. If you go in the wireframe, then you can find that the rectangular mesh has been created. The rectangular domain mesh of the rectangular domain has been created. Now where is the pipe? Pipe will be made with the help of snappy hex mesh. Okay, as I have given one video of a snappy hex mesh, there I have told you that any complex uh, you know uh, complex shape you have to insert in the rectangular domain, so you have to use a snappy hex mesh. Okay, there is no other option. Okay, so what I was telling you is, like, after block mesh you don't run the snappy hex mesh again like individually, because the next command, if we'll go at an all run file, yeah, here it is, so I'll just close it down, and if we'll go in all run, so the next command, just skip this one, this is I'll tell you afterwards, but this one is the snappy x, and the main command is snappy x mesh. Okay, so if you run here, like if you are having less number of cores in your machine, okay, like me, I'm having 4 number of cores, snappy hex mesh will not give you the good quality mesh which you want. The command is same, you have done all the settings right, you have done everything right, okay, but still it will not give you the good mesh, the good circular mesh, the good pipeline hole with the mesh and the refined mesh. Okay, I will show you in the ParaView the result I'm having. I'll show you in the ParaView, just a minute. So what that is the thing. Okay, but if you run the same snappy hex mesh in a good machine which is having good number of cores, it will give you a very good mesh. Okay, it will give you the desired mesh, the desired setting, the desired quality of settings which you have done in this 2D pipeline score tutorial. Okay, and it will give you the same result. Okay, the good quality mesh. Okay, so the thing is, what I want to tell you, that OpenFOAM simulation depends on the number of cores. Okay, if you are running the simulation on less number of core, yes, it will, it will not give you the even the good mesh. Okay, let's do not talk about the analysis result. Let's It will not be able to give you the good amount of mesh which you want. Okay, but the same if you will run in a high number of cores machine, it will give you the good result. So why I am telling you, because sometimes what it feels like, okay, this thing nobody can tell you. Okay, this thing nobody can tell you. I know, because I'm having experience in this. I ran the same snappy x mesh in my laptop. It was giving a very bad circular mesh around the pipeline. I ran the same Snappy Xmesh in the HPC high power computing system of my college during my MTech. It gives me the same thing, the a very good mesh which we wanted for the analysis. So that is the thing. Okay, so this is a tip for you all, that you may have done each and every setting a good setting, but it was not giving the good mesh, the good result, because you are not having the optimum number of resources. Okay, which means the number of processors, the number of cores in your laptop or your computer or the machine you are using. Okay, for the CFD analysis. All right, so please keep this in mind. Okay, so this is the thing. Okay, so I will not run the the other part. This I was just showing you, so that's why I comment down the other parts. Okay, so here you can see that mpi run minus np 16. Okay, so 16 means it is using 16 number of cores. Okay, 16 number of cores. So if you wanted to change the core, like if you are having 12 cores of machine, so first you have to change the cores here, like make it 12 here. Okay, press ok, and then you have to go inside the system directory, and there you can find the decompose predict, and here also you have to change the number of subdomains to 12. Okay, so make sure to change the number of cores, the number of subdomains in both the files. Okay, in the all run and in the decompose predict. Okay, and if you are running the simulation in a HPC high power computing system, so there you have to submit a slurm file. So there also in the slurm file you will not directly run all run. Okay, you have to submit all the make a slurm file, and that slurm file will contain all the commands of these all run file in the that slurm file, and that you will submit, and then it will start running your simulation. Okay, so there also you have to change the number of cores. This command, in this command you have to change. Okay, that is the thing which I wanted to tell you. Okay, so let's move on to the result section, because I don't want to waste the time, because I'm not able to run it on my machine. Okay, because my machine is not able to having that capability to run it good okay, so let's move on. I have one of the solution which I've done, which I ran during my MTech in HPC. So I ran it for 100 seconds. Okay, so let's view the result. Okay, let's view the result in ParaView. So yeah, yes, yeah. So how much time it will take to complete? I have run on 16 cores only on HPC. So basically it takes time around, if everything is fine, you have set up everything correctly, then it will take around 16 to 17 hours. Sorry, not 16 17 hours, 7 to 8 hours to complete the full simulation, up to 45 seconds. Okay, by default into the Pipeline Scour, the setting by SEDFOAM people have done up to 45 seconds. If you want to increase up to 100 seconds, yeah, then it may take 12 to 13 hours to complete. Okay, I don't remember, I don't have that log file, because it was very big and it is of no use, unnecessary file, so I just deleted it. I just kept the result. Okay, so yeah, here you can see, if I'll just go to the wireframe and just show you this refinement which I was talking about. This is the refinement. Okay, you can see that here the mesh is coarse, and here the mesh is fine. Okay, and here around the pipeline, you can see around the circular hole which is representing the pipeline, you can see that what good quality of mesh has been made. Okay, so that is what I was talking about. If I just try to run a snappy hex mesh in my system, it will complete a snappy hex mesh, but it will not give me this good quality of mesh. Okay, so initially I used to thought, okay, the error, I am doing any error, but when I just ran the same thing, I just have a thought, okay, just run it on HPC. Okay, so and it ran, it got me a very good result. Okay, so I was like, okay, that is the thing. Okay, so that is these error I have faced, and I've solved it by myself only. And these type of error, people find it difficult to find, like how to solve this. Now ChatGPT is here. Okay, but for to ChatGPT to solve, you have to give them the input, the exact input. Okay, and the input here is number of cores. Okay, like if we are having less number of cores, will it affect our snappy hex mesh? Yes, then ChatGPT will give you the answer. Yes, it will affect. Okay, otherwise you will just search in ChatGPT. Okay, I was not getting. I've done everything correct, and I'm not getting. Then it will give you multiple answers, which will not be the solution of your problem. Okay, so that is the thing. Okay, that is the thing. Initially set form, I think basically like on an average every more than 70%, I think every tutorial is requires high number of cores. Okay, high number of cores. Okay, so this is the thing. This is the mesh which you will get after running snappy hex mesh. Okay, then we will just go in surface, and then I'll just go in alpha A. Okay, yeah, here you can see that these are the thing. Okay, now what is this? Okay, so it's basically this red portion is representing the sand bed, this circular one is representing the pipe. You do not require to make a full pipe. Okay, it will not be required to make the full pipe, only a circular hole. You have made a pipe, cylindrical pipe in .stl format. Okay, and then what it will do, only with the help of .stl, it will just it must be here if I'm not wrong. No, it is not here. Okay, so that .stl, with the help of .stl, it will make a hole. Okay, so it is not required to make a cylindrical pipe, because it will unnecessarily create a very huge mesh, and it will be of no use. Okay, so that's why they've only taken the circular part, so circular pipe. Okay, that is the thing. Another part is, okay, so that is the part. The blue color is representing the water, and the red color is representing the sand bed. Okay, so this is the sand bed, and sand bed is represented here by alpha. Okay, so alpha dot A is representing the sand bed. Okay, this is the sand bed. All right, so and now if I'll just run, because it is having the 100 seconds, so let me zoom out, let me zoom in. Okay, you can see that the sand bed is, because we are giving the velocity here, you can see the due to the flow of the water, you will see that it will start moving. Okay, the sand will start moving. Okay, and here you can find that this scouring is happening. Okay, you will see a profile of this the sand bed will be found. Okay, so yeah, here you can see that sand is getting removed because the water is flowing. Okay, because the water is flowing. All right, if I have the result, if I have one or two videos, let me show you, or we will try to make it here also, like with the help of the vectors. Okay, that is a very good result which I have made here. Okay, let me check in my computer till you can just see that here it is running or not, it is running good or not. uh, I think yes, here it is. Okay, so it ran up to 14. So yeah, again you can see that my CPU, my RAM is 24 GB and it is using half of the RAM. Okay, sometimes what happens is like it use around 90% of my RAM it is using. Okay, so what I recommend, if you are doing GFD analysis, please have a laptop or computer of minimum 16 GB. Okay, and if you can, if you wanted to ask me what on an average, so on an average you must have 24 GB RAM. Okay, always if you are buying a laptop for the CFT analysis, always try to buy a laptop with two slots. Okay, if it is having 8 GB, that's fine, you can buy 16 GB RAM from Amazon and you can insert it by your own. I've done the same thing. Okay, I'll try to make one video like what type of configuration I am having in my laptop. Okay, so this is the thing. Okay, so please, okay, it's fine. Okay, because if you buy a 16 GB RAM laptop, you may find it costly. Okay, what you can do, find it, buy an 8 GB and ask them that if it can be upgradable or not, if it is having a two slots or not. They are available. Okay, and you just buy a RAM, and RAM will cost you, where it will not be costly. Just buy it and insert it by you, and you can see that it will be increased, and then you will be able to run the jobs very in a good manner. Because what is happening is like my friend, my classmate is there, he used to work on answers, and then he has some curiosity to run the same simulation in OpenFOAM. He has done everything, but when he tries to run the simulation in the post processing part in ParaView, his laptop crashed. Why? Because it is having 8 GB. So he used to ask how it ran in your laptop. I used to tell him, just see this, see the RAM. Then he was like, okay, this is the thing. You're having 24 GB RAM. Okay, so that is the part. That is the part. Okay, so yeah, one result I'm having of velocity. This is one case I've done in the tandem pipeline configuration. Okay, so yes, this is the case which I've done in tandem pipeline configuration. And if you'll see the velocity part, so here you can find that yeah, so here you can see that the water is flowing. This is the water part and this is the sand part. Okay, so water is coming and it is pushing the sand here. Okay, it is pushing the sand here. I'll just show you this case only. It is very easy. I've not done much thing. I've just only changed the coordinates of the pipe in the CAD software and just inserted it and take like this, and then I just kept everything in 2D pipeline scour same, changed nothing, and then I just got this type of result. Okay, so here you can see that here the due to the flow of the water, the upper part is representing the water flow. Due to the flow of the water, it is pushing the this you know the sand, and due to that pushing, the scouring is happening. Okay, that is the thing. That is the thing which I wanted to tell you. Okay, so this is the part. Okay, if I can show you the velocity, yes, here you can find, here you can see. Okay, so yes, because if I'll try to make the vectors, it will take time. Okay, it will take time because you can see that for running 1.5 seconds only, it is taking time. So that's why we'll try to make another video in which I'll show you that how you can just make vectors. So one result I've made, I'm not having it right now with me, but that is a very good result which I've got. And in that result, it was showing vectors were coming and flowing, and it was showing that how water is pushing down the sand. Okay, that is the part. No, I don't have that video. Let me check if I'm having something in PPT. Yes, I have received emails from the people to get help. So I will just I'm very happy to help you all guys if you're facing any type of issue in running the OpenFOAM simulation. Just please, man, please, you can just mail me on cfdsimplified@gmail.com, and there you can just uh, yes, here it is. Yes, I'm having. So this is the presentation. This is the presentation which I made for my project presentation. Okay, so here one animation video I have made. Yes, here it is. So here you can see that. Yeah, here you can see that. Yes, I got it. So here, so this is the representing the water vectors of the water flowing. Okay, so here you can see that if I just run frame by frame, what will happen, you can see that the, oh, I have to zoom in. Okay, it's okay. So here if I just run frame by frame, you can see that the water is coming and it is you know pushing the sand, okay, away from the contact is increasing. The distance the contact is not there in between sand and the pipeline, and the gap is increasing, okay, with the when the water is pushing it. Okay, so here you can see that. Okay, yeah, here you can see that it is like this. Okay, so yeah, you can see that up to 20 seconds how much scouring has been done. Okay, and that is not good. That is not good. So that is the thing. That is the thing. Okay, so it's a very good simulation, very good tutorials. Many papers you can also find, uh, whenever it will be, if you can search on Google Scholar, you will find many papers on it. Okay, so yeah, this is the thing which I wanted to discuss in 2D, in this 2D pipeline scour. Okay, one more thing is there, but let me check if I'm having the Python file or not. Like there is one result, okay, that no, it is not here. Okay, so yeah, like this is the result. You can find, yeah. So this plot has been made. This and this plot has been made with the help of Python only. Okay, this one also. This one has been made with the help of Python, and this one also has been made with the help of Python. Okay, so these images you can find, similar images you can find on SEDFOAM website. If you'll go inside 2D Pipeline Scour tutorial, you can find this. So this you can also make there in the tutorial part. If you just go inside the the this SEDFOAM uh, tutorials py, you can just enter py. Okay, py means Python. Okay, py. Okay, so here you can find, okay, this plot, where it is, yeah, plot depth 2D pipeline scour. And so this one, this Python code is for this result, is for this result. This is representing the depth. You can see maximum scour depth. Okay, and this profile, plot profiles to the pipeline scour, this is for this one, for drawing the profile. Okay, I'll just make another video where, because some settings you have to done in Python to read your results. Okay, because when I ran the Python script, as raw, as it is given in the SEDFOAM tutorial, it was not running. It was giving the error because they are using some old methodology which Python have removed from their libraries. Okay, so that is the thing. So that changes you have to do. I'll just show you that those changes, and then you can just you can also make the changes in the Python script and get your results of 2D pipeline score. plots of 2D pipeline score via Python. Okay. All right. So let's end this video here. Okay. I don't have much details to tell you, but yeah, in the end, I'll just tell you that SEDFOAM, you will find it difficult to run. Okay, it is not. I found OpenFOAM tutorials easier to run as compared to SEDFOAM. Okay, you have to do many settings, and there are things which you don't have control on that. The thing which I've told you in the snappy hex mesh part. Okay, so because if you are having low processor in your machine, then it will give you bad mesh, and if you run the same without making any changes, the same file, this of snappy hex mesh in a good processor, good number of processor, you will find it running, completing it, and you will get a good mesh, the required good mesh, good quality mesh required for the analysis of the CFD. Okay, so yeah, so these type of things are there which you don't have any control. Okay, I think I have told you one error also in MPI run when I was running the slurm file. I think I've discussed about that. Okay, let me open here also. Let me close this ParaView one because it is okay. Oh, this is the thing which was making errors. Okay, so if I'll go inside the 2D, ah, okay, so it it was running up to here when I was just submitting the whole commands in a slurm file and submitting that slurm file in the HPC of my college and try to run that slurm file. It was running up to here, but it was not running the solver. I was like, I'm doing the error, I'm doing the error. I just I was very very exhausted and very like I tried everything, it was not running. Then what happened is like then I just decided one day that no, I'm just going to you know remove this. For 48 hours I think I've only took 2 to 3 hours of sleep only. I think I have not eaten much, but I just what the error, what was coming due to why it was not running, because I was just pasting this whole line also in the HPC slum file. Okay, what was happening? This and okay, why do you put this and in OpenFOAM or like this? Because it will keep this log file in the background so that you can do other things in your that tab. Okay, because right now we have the multiple tab option, but yeah, you can do anything what you want. It will be running in the background part, it will not be showing you. Like if you run only if you run SEDFOAM RBGH, so it will start running on your screen and it will be running the simulation, okay, continuously. So log is for that. It will create log file, and that log file will not be displayed to you, it will be running in the background. You can just uh, if you wanted to see, you can just by typing one command you can just see it live in the HPC. If you submit this with this and in that slum file, what this and will do, it will kill the command, it will kill this set this parallel command. That is error. I don't know why it does that I don't know, but yeah, it kills. And this is the result. I was not, so I just like how the hell I have solved, I know only. So is this your, because sometimes what happens is like you don't know, like okay, ChatGPT is here, but you don't know that what input you have to give to ChatGPT to solve your problem. The part is this: there are things available on Google, there are things available on ChatGPT or DeepSeek, but there are some things which you don't know that what line you have to type, okay, exact line for your problem, because you also don't know, and you are putting your effort, and the person for who you are working, whether it's a research work or you're doing any job, they only want result. Okay, because result matters. So you have to give the result, and you are putting everything, you they will not find it like, okay, you are putting the effort, you're not getting the result, nobody sees your effort, everyone just want result, and that is a positive result. Okay, so that is the thing. So yeah, you may find it difficult, but yeah, it's fine. If you are having any issues, please you can mail me. I will be very happy to help you out. Okay, I may take time to reply, but yeah, I will be very, very happy to help you out. Okay. All right. So let's end the video here, and we will meet in the next video. I will try to upload now, upload the videos regularly on the YouTube channel. Okay. Yeah. So thank you for watching.